Okay, so continuing, let's look at one of these, couple more of these today. And this probably maybe go through two today, and that's probably good. Okay, so we want to sketch this rational function. So what do we do? Throw out some ideas here. Say it again. Okay, factoring. That'd be a good idea. Uh, well, I guess we can still factor it. Um, if we factor this, we might come back and look at this one too. Top's already factored, right? What can I do on the bottom? What can I do on the bottom? Take out a 2, and then I'd get x squared minus 1, right? And so what does that factor into? Okay, that tells us a lot. Do we have a horizontal asymptote, first of all? You guys got to tell me. How come, Bella? There you go. Degree of the numerator is bigger than the degree of the denominator. So we don't, right? Okay, so what if we wanted to determine like what the end behavior is? We could do that, right? We could do end behavior. If we look at the limits at the infinities, I guess I don't need to write the word limit. We're not doing that. As x approaches positive or negative infinity, all we have to do is consider the first two terms, right? So f of x would just equal x to the fourth over 2x squared, which simplifies to what? X squared over 2. Okay, so what kind of end behavior is that? Yeah, it's that, isn't it? Positive even, right? So that's telling us the end behavior. We could add that down here if we want to. If we did a limit as x approaches negative infinity, y is positive infinity, right? It's doing that. If we take a limit as x approaches positive infinity, y approaches positive infinity. That's just our even end behavior, right? So we got that. Let's see, do we have any, no horizontal asymptotes, you told me, which is correct. Are there, what else we need to do here? Tell me more. There's no horizontal asymptotes. What other kinds of asymptotes would we need to find? Okay, vertical asymptotes. Okay, so where would vertical asymptotes potentially occur? Zeros of denominator, right? Okay, so what are the zeros of the denominator? 1 and negative 1, okay? So we've got when x is negative 1 or positive 1, the function's undefined, right? Because the denominator is 0. So x cannot equal negative 1 and x cannot equal 1. So give me thumbs here. Thumbs up for yes, thumbs down for no. Are those vertical asymptotes? Are they vertical asymptotes? Okay, how do we know? How do we know? Griff, how do we know if they're vertical asymptotes? What's the criterion for that? To be a vertical asymptote, say it again. Multiplicity could be higher than 1, but to be a vertical asymptote, they have to be zeros of the denominator. But what else? What's our rule? Okay, they're not zeros of the top, right? They have to be exclusive or unique factors or zeros of the bottom. Let's go back and look at our list real quick, right? So vertical asymptotes exist at values of x that are zeros of the denominator, but not zeros of the numerator, right? Okay, holes could, when we get a simultaneous zero, then we've got to do a little bit more work, right, to figure out what's going on. But if we get a 0 of the bottom and not the top, automatically we know it's a vertical asymptote. So at x equals -1, yeah, that's the 0 of the bottom, but not the top. The only 0 of the top is what? Is 0, right. Okay, so then, yeah, both of those are going to be vertical asymptotes. So we can add those to our graph, right? -1 and +1, we get vertical asymptotes. Okay, that's helpful. Do we have any x-intercepts? Where would x-intercepts occur? Zeros of the function, but it's a fractional function, right? It's a rational function, meaning fractional function. So where are fractions equal to 0? Where the numerator is 0 and the denominator is not, right? So where's the x value that makes the numerator 0 but the denominator not 0? What would it be? Yeah, right. So it's going to be at x equals 0. Why? Because x equals 0 is a 0 of the top but not the bottom. You can. If I plug 0 in for x, I'm going to get 0 divided by 2 times 1 times -1. 0 divided by a number is 0. Right? Okay, you end up with something on the bottom. You end up with a -2 on the bottom, but it doesn't really matter. You know you're going to get a number down there. 0 on the top divided by a number is going to give you 0, right? So we do have a 0 of the function at the point x equals 0, y equals 0. Okay, so we can add that to our function. So we know we've got a point there. Okay, that doesn't tell us very much though, does it, right? Now, we do know one important thing though. How many x-intercepts are there in the entire function? 1. It only ever touches the x-axis in one place, that's it. Okay, never any place else. Now, when you're thinking about, when you've got vertical asymptotes on a graph like this, you kind of think about it as being like separate universes. I've got this part of the function over here on the left that is completely cut off from the part next to that, which is between the vertical asymptotes, which is completely different than the function on the other side. They're totally disconnected, right? So we've got to look at each of those individually. Let's start with the middle because we have a point there. What are the possible things that could be happening in the middle? Because we have to have asymptotic behavior and it has to go through that point. So, Colson, tell me one thing that could be happening in the middle between the asymptotes. It could be. It could be going like this. So there's one possibility is that it does that. Okay? What's another possibility? Goes up. Yeah, it could do this. What's another possibility? Yeah, it could be doing that. Good. It could be going back. There we go. It could be doing this. It could be sticking to that asymptote, coming down, going through that point, and then sticking to that asymptote, right? Or the other possibility would be if I flip that around and it did that. No, I'm not sure. So, okay, so now how are we going to know which one it is? Say it again. Well, we can't look at end behavior here because it doesn't really have x stops at 1, right? Now in calculus, we'll have some different tools, but for now, what's the only way we could know? Test points. Yeah, we could just plug in test points. So this is at -1. We could plug in a test point like at -1/2 or something, right? So if we go to our table and we try a test point at -1/2, what's going to happen? If I plug -1/2 into my function, and it's already simplified, I can't cancel anything, what's going to happen? Well, if I evaluate f of -1/2, all we have to do, I don't need to know the value, right? I just need to know a sign. Is it going to be above or below? Does everybody get that? Because it can only cross the x-axis in one place. So if it's above, then it means it's sticking to that asymptote, right? If it's below, it means it's sticking to that asymptote, okay? So we just need a sign. Well, here, look, we've got this function in factored form. Well, what is negative 1/2 to the fourth? What's any real number to the fourth power? Positive or negative? Positive, yeah. So we get positive on the top. On the bottom, we're getting 2 times negative 1/2 plus 1 is, so positive 2. That's positive, right? What's negative 1/2 or negative 1/2 minus 1? Negative. Yeah, it's negative. Okay, so then that's going to give me positive on the top divided by what's on the bottom? Negative, right? What's positive divided by negative? It's negative. Okay, so we know that we have a negative value there. So that tells us that this guy is doing that, right? I could do the same thing for positive 1/2, right? If I do the same thing for positive 1/2, I get positive on the top, I get positive times negative, same thing, right? So I get negative again if I plug in a test point at 1/2. Whoops, that's negative. Okay, so I know I got figured out what it does in the middle. It's doing that. Okay, now I got to go to the sides, figure out what's going on. Okay, so what if let's take the right side. How would I know? Okay, let me ask you this. What you actually already know. You don't even really have to pick a test point because we know the end behavior, right? You guys told me it was positive even end behavior, right? We could also get that by, if we hadn't done the end behavior test, we could have just picked a test point too. So let's do that. Let's pick a test point just to show that these are consistent. What would be a good test point to pick on the right side? One's the vertical asymptote, so well, no, we want to pick one. We've already know what's going on between the asymptotes. Now we got to figure out what's going on in this universe. Yeah, let's pick 2. So if we plug 2 into the function, what are we going to get? We're going to get positive on the top. I'm going to get 2, which is positive, times 2 plus 1, which is positive, times 2 minus 1, which is positive. So I get positive. Okay, so if I know that it's positive, what's this thing have to be doing if it never ever touches the x-axis out here? I mean, if it's positive at 2 up here somewhere, it has to be coming down from up here, doesn't it? Because it can't cross the x-axis. If it did, we'd have another x-intercept, which we didn't have. We only had 1. So it's got to be doing this, right? And then what does it got to do if it's got no horizontal asymptote? It's got to turn around and zip up somewhere, right? Okay. You guys, do you see how we get that? Right? It's the only thing it could be doing, right? Okay, what about the other side? Well, there's a couple ways we could do this. Get the other side. We could pick a test point at -2. That's fine. So if I plug -2 in, what's going to happen there? I'm going to get positive on top. I'm going to get on the bottom, I'm going to get positive, negative, negative, right? So what's the overall sign of that fraction going to be then? Going to be positive, yeah. Okay, so then we know it's going to do the same thing over here, right? If I plug in -2 and I get a positive value, I know it has to be doing the same kind of thing. It's got to be sticking to that asymptote and it's got to be turning around and going up somewhere, right? Because it doesn't have a horizontal asymptote, okay? That makes sense. And plus that end behavior thing is a great idea, right? Why wouldn't we find the end behavior? How do we find, again, what do we do with the end behavior? If we're looking at what's going on at the infinities, I only look at the ratio of the leading terms, which is easy to simplify, right? So what does this function look like really far to the left or right? It just looks like the quadratic function x² over 2 if I zoom way out. So I know what that is, okay? There's my graph. There's my sketch. Okay. Is it starting to? I know you just got to do a bunch of problems to get this stuff. Okay. I was going to show you one other thing on this. So look at this function f of x. This is kind of cool. Remember we talked about symmetry just a little bit? This is another great way to do these problems. There's so much, and we'll hit this stuff a lot more in calculus. This is just kind of a first glance at this analysis stuff. But what do we know about? Okay, do you guys remember the tests for symmetry? We talked about symmetry a little bit earlier in the year. Doesn't come up a lot in algebra 2. Remember we had even symmetry and odd symmetry? Remember talking about that? Okay, so even symmetry is reflective symmetry about the y-axis, right? So even symmetry is line symmetry about the y-axis. Hi. Oh, great. Thank you. All right. Shane, there you go. You got mail. There you go. Okay. So we got line symmetry about the x-axis, right? Folding symmetry about the y-axis. What's our test for that? Okay, the test is f of negative x equals f of x. If I plug in negative x, and we get the very same function back. So we'd say that the function is insensitive to the sign of x. Then that's even symmetry. As opposed to odd symmetry. Remember what that was? That was rotational symmetry about the origin. That was the stuff. Remember where we take the graph and we would just rotate it 180 degrees about the origin and then it would overlap with itself, right? What was the test for that? Well, the test for odd symmetry was f of negative x is the opposite of f of x. So if I plug in negative x and I get the opposite of the original function, it's odd symmetry. If I plug in negative x and I get neither one of those things happening, there is no symmetry. Which one does this have? If I plug negative x into this, what's going to happen? What is the quantity negative x? I'm going to get negative x to the fourth over, it's even, isn't it? Over 2 times negative x squared minus 2, right? Everybody see that? So it's not going to matter, is it? Because I have even powers of negative x are just, that doesn't change anything. Negative x, quantity negative x to the fourth is just x to the fourth, right? Everybody get that? So where do we get the word even and odd from? The powers of the exponents for polynomials. Remember that now? We talked about polynomials as having even and odd symmetry. An even polynomial would be one where it only has even powers of x. An odd polynomial would be one that only has odd powers of x. Okay? So here we've got, this is even. So what's that mean then? That means that this thing should have reflective symmetry about the line y equals x. Well, it does. Look, there's the line y equals x. We can reflect this thing and it overlaps perfectly with itself, right? Everybody see that? Okay, so the nice thing about that is if you exploit the symmetry, we could have cut our work in half on this. We really only would have had to do everything from 0 up on our table, and then we could have just reflected it to get the rest. Okay? Do you have to do all this stuff? No. I mean, you can do the same way you want to, but these are all tools that you have available that eventually you're going to use. Okay? Let's look at one more. Okay, and there's the actual picture of what this thing looks like if you graph it on a graphing calculator. Okay? All right, so what about this guy? Now, there's something else going on here that's very useful. So does it have a horizontal asymptote? It doesn't. You're right, because the degree of the top is bigger than the degree of the bottom. Doesn't have a horizontal asymptote. If I were to divide these things out, though, if I were to look at the limits, what's going to happen? Well, I'm going to get x squared over x, that's x to the first power. I'm going to get some kind of a linear function. Okay, so there's a really good thing you can do with this. Anytime the numerator is exactly 1 greater than the degree of the denominator, you can divide out those polynomials, and what you're going to get is the equation of a line plus some rational piece that's going to involve the remainder, right? Like I can use synthetic division here to divide this out, right? It's easy to do. So if I use synthetic division and I divide out this polynomial, what are the numbers that go on the top? 1, 1, 0, 0. Good. Okay, 1, 0, 0. There's my remainder box. What number goes out front? 2. Good. Okay, so if I divide that out, I bring the 1 down. 1 times 2 is 2, plus 0 is 2. And 2 times 2 is 4, which I add, and I get a remainder of 4, right? So what does that mean then? That means that this function is actually equal to if I divide it out, I get the polynomial, that's my constant, so that's the coefficient of x, right? I would get 1x plus 2 plus the remainder for over what? Over x minus 2. Okay, now again, this is a pretty advanced topic. This is not normally an Algebra 2 topic, but it's good to see this now before you use it in the future. So if I were now to take the limit as x goes to infinity, right? If I let x go to infinity, positive or negative infinity, what's going to happen to that fraction? It's going to get smaller. What's it going to approach? No, as x approaches infinity, you said the fraction gets smaller, which it does. What does it approach? Yeah, okay, well, yeah, what would that be? 4 over infinity would be, you said it. What is it? 0. Yeah, it approaches 0, right? As x gets really, really big in either the positive or negative direction, I'm going to get a huge number on the bottom. Doesn't matter if it's a huge positive or a huge negative number. 4 divided by an infinitely big number is 0, right? Because the bottom of the fraction is getting big, so the fraction is getting much smaller and approaching 0, right? It's getting smaller. Like what's bigger, 1/1000th or 1/1 trillionth? 1/1000th. 1/1000th is a lot bigger, isn't it? Right? Okay, so then this whole thing approaches 0, so what's left behind? Look at that. That looks like a line, right? So as x approaches the infinities, that extra rational term gets extinguished. It goes to 0, and we're left with something that looks exactly like the line y equals x plus 2. That is what we call a slant or an oblique asymptote, right? So when we're graphing this thing, we can actually put that into our graph. I need a piece of graph paper here. Whoops. Um, okay, so when we make our graph of this thing then, okay, what's that mean? So we've got the line then. We can put in the line as an asymptote, the line y equals, what was it, x plus 2? Is that what it was? I forgot. x plus 2. Okay, so if we put that line in, there's one of our asymptotes that really far to the right or the left, the function's going to stick to that line. Okay, what else do we know about this thing? Well, it's already factored. Are there any unique zeros of the denominator? At 2, right? So what's happening at x equals 2 then? Vertical asymptote, because it's a 0 of the bottom but not the top, right? So then x cannot equal 2, and that's a vertical asymptote. So at x equals 2, I guess I can keep going with that guy. We've got something like that. Those are my two asymptotes. Those are going to guide the behavior of the function. Do we have any zeros? Where is it going to be? Where's the x-intercept of the function? I think where would a fraction equal 0? Where the top does, right? So it's 0. Yeah, the unique zeros of the top. At x equals 0, the numerator is 0, denominator is not, so the fraction equals 0, right? So we got a point at 0, 0. Okay, that's the only x-intercept, so we're done. We're not totally done, I guess. We're mostly done. What does the right part of this function have to look like if it's going to stick to the green asymptotes and go through that point? Okay, but it can't go up, because if it goes up, it's going to cross through that. It's got to go down. So it's going to do this. It's going to go up and do that, right? Everybody see that? Okay, what are the options on the other side? There's only two choices. Actually, there's only one choice. We already know what it's going to be, because it only crosses the x-axis, only touches the x-axis one time. So if it's got to stick to those axes, it's got to be this one up here, right? Because it can't cross through the x-axis. If it were the bottom one, it would have had to cross through the x-axis, which it can't do. It's only got one x-intercept, and we already used it, right? So that's our graph. Okay, that's pretty amazing, though. I mean, that took what, 2 minutes, and we get this whole sketch of this thing that's pretty accurate, right? Question. The top, because it has to go through that point, right? And if we did one in the top left, you couldn't have both of those, because then it's not a function. It violates the vertical line test, right? The function can only be in one place or the other. It's either going to be above or below the slant asymptote. Why is it what? Because if it were down here, it can't be down here, because if it were down here sticking to the asymptotes, it'd have to cross the x-axis again, which it doesn't do. There's only one x-intercept. So you could have chose the bottom one or the left one, right? Say it again. The bottom right here. What do you mean? So this one? Because the x-intercept has to be there, so it has to be the purple graph. There's no other way it could be. Okay? Make sense? Okay. The exact function? So to find the exact function, I mean, you'd graph it on a graphing utility. But what we'll be able to add in calculus, though, that would help a lot is we'd be able to find the minima. We'd be able to find the locations of those valleys, that valley and that peak. And once we knew what those were, it makes it pretty easy to graph, right? So that's the actual graph right there. Okay. Let's do one more. We got to get one more. How about this one? Okay, so if we're going to factor the top, which we can do, we can take out a -1. Good. Negative x, there you go. Negative x times what? X plus 1, there you go. Okay. Okay, looking at our original function, do we have any horizontal asymptotes? No. Okay, are there any other types of asymptotes that we could calculate? There's vertical. Yeah, where's their vertical asymptote? At -4, right? Because -4 is a zero of the bottom, but not the top. So we can add that value. X cannot equal -4, and that's a vertical asymptote. Okay, so that's helpful. Okay, there is no horizontal asymptote, but what do you notice about the degrees of the top and the bottom? The degree is higher, but how much higher? 1. So what can we do? We can do division. In this case, we can do synthetic division. If the bottom, like what if the top were cubic and the bottom were quadratic? Then we'd have to do long division, but we could do division, do the easiest kind of division that you can, and we're going to be able to come up with the equation of the slant asymptote, right? If it's, does that make sense? Okay. So if we divide this out then, synthetically, what goes on the top? What goes out front? So I bring this guy down, I get -1, 4, 3, -12, -12, right? Everybody see that? So if I write this out then, if I write this out as a quotient, if I divide out the quotient, I get, here, let's do it this way. Let's do it down here so we don't confuse it with that. So then what does the bottom tell us? -x plus. Okay, good. And if we take the limit as x approaches plus or minus infinity, what's happening? Yeah, that one's going to 0, right? Because I've got x's on the bottom and a constant on the top. So we get infinitely big denominator. So it goes to 0. And that's our slant asymptote right there. Okay, -x plus 3. So then we could go to our graph down here, and we can add both of those. We've got a vertical asymptote at -4. We've got a slant asymptote, and what was that one? It was -x plus 3. So, right, so it's doing that. There's our two asymptotes. And now we just have to graph it around those. Do we have any zeros? -1. What else? 0. Yeah. So -1, -1, 0, and 0, 0. We can graph those points. And we said 0, 0, right? Okay. What the heck's going on there? What is happening there? -1 and 0. Okay. Oh. Oh, I see what it's doing. Yeah. Okay. So what's it have to be doing then to the right of the vertical asymptote? What's the only way? You just got to think about it a little bit. I mean, we could pick test points, but we don't have to. How is it going to stick to the red asymptotes over here and go through both of those points? Well, okay, but it can't be crossing through that asymptote. So what's, do you want to draw that? Okay, but if I go through like this, then I'm going to cross that asymptote. That's not. Yeah, that's all it is.
Yes, to me.
It's just this.
That's exactly what I remember. No,
I thought there were lots of curly cues and dipsy doodles in there. At least. Okay, so anyway, that's what we get on the left side. What are we going to get on the right side? If we have no x-intercepts over there and it's got to stick to that thing, what's it going to do? We can't really see it very well, but it would be up here, wouldn't it? It'd have to do one of these where it comes down and goes up like that, right? You get what I'm saying? Because it can't cross the x-axis, so it can't be on the bottom side of this line. If it were, it would have to go through the x-axis, and it can't. It's gonna, yeah, but it's gonna be the one that's kind of, it's off the graph. I didn't pick a very good graph here, right? But it's gonna be the one that's way up on top up there. So if we graph this thing, let's just see what it looks like. If we just cheat and graph this thing, you'll see what I mean. If I zoom out, see what I'm saying? There's the upper part, right? If we graph the asymptotes on this, x equals 4, oops, x equals -4. There's the vertical, and then we had the line y equals -x plus, what was it, plus 4? No, plus 3, I think it was. Yeah, it's that one, right? Okay, so there's our graph. Makes sense? And look at the x-intercepts, right? There's our x-intercepts, -1, 0, 0, 0. Right? Okay. All right, you can work. You didn't get much time today. You get a full day tomorrow.